Come to question 2. Now, predict and explain the variation in enthalpy change of hydration for the ions of sodium, magnesium, and aluminum. One of the things you realize that this sodium is in a different group, also the magnesium is in a different group, and now you need to realize that what we check in is that we are going to ensure that our response is very keen because you realize that they belong to the same period, but they are from the different groups. Now, first step we need to show is we need to explain it fully to earn these 3 marks. So you'll just say the hydration energy increases from left to right due to an increase in the charge. That will earn you a mark. So that will earn you a mark. So this one will earn you a mark. Then ionic radius decreases from left to right. This will also earn you a mark. Then you say due to the size of radius, when it is increasing, it increases the force of attraction between the water molecules and the ions. Then that also will earn you a mark. Then you'll have and your 3 marks. Question B, figure 2.1 shows an incomplete energy cycle. Now, in this, you realize that we are having magnesium 2 ions in gaseous state together with 2 chlorine ions in gaseous state in this line B. In this step, they are undergoing change 1, which is lattice energy of magnesium chloride. Now, they will give us magnesium chloride solid, which is an ionic compound formed from the gaseous ionic ions to give us that. Now, step number 3, we realize that enthalpy change of solution of magnesium chloride, giving us magnesium chloride solid, which will dissolve to give us line C. Now, we are being asked in question Roman 1 that complete line C on figure 2.1 includes states symbols. Very important. This key is part of the marking. So you ensure that you give them the ions very well. Then you ensure you bring in the states equals. So this is what will be being formed. This one will earn you a mark, which will be 1 mark. Question number Roman 2 says use both word and symbols to identify change 2 on figure 2.1. Now, use changes in 1 and 3 as examples of how this should be done. Now, you can see, for example, 1 and 3. So, what you just say is that enthalpy change of hydration of magnesium. Why did we say that? Because you realize that magnesium and chlorine they are in gaseous state and they are changing direct to aqueous state. Now, what happens is that they are undergoing the enthalpy change of hydration. So you will just say the enthalpy change of hydration of magnesium ion and chloride ions. That one will earn you a 1 mark. Then also this one, the simple will earn you another mark. Then you will earn your 2 marks. Next question, Roman 3 says, calculate the value of lattice energy of magnesium chloride by selecting and using appropriate data from this table. So this is a table that will help you to answer the question. So what do we need from this information? What do we need just the lattice energy for magnesium chloride, which you are going to calculate. Now we will need the hydration energy, and we also need what? The enthalpy of solution. Now, what do? We say that change in lattice equals to change in hydration energy minus change in solution. So your work is to put into values. So we are going to use this data. Why? Because enthalpy change of solution of magnesium chloride, it's needed. Then we also look for enthalpy change of hydration of magnesium ions. Then we look for chloride ions. Why are we multiplying by 2? Because we need 2 molecules of chloride ions. And the answer will be this one. This one will earn you a mark, and a mark. Now, question C, define entropy, the number of arrangement of particles and of the energy in the system. So, it's the number of arrangement of particles and also the energy in in the system. And that's what we refer to as the entropy. Good. Question D. At 25 degrees Celsius, enthalpy change of solution of compound Z is plus 26 kilojoules per mole. The entropy change of solution of Z at the same temperature is plus 52 joules per Kelvin per mole. Calculate the value of Gibbs free energy change for Z at this temperature. Now, one of the things you need to remember is this equation that change in Gibbs free energy is given by the enthalpy change minus temperature multiplied by entropy change. Now, your work is to substitute because you have everything. The temperature we have 25, which you convert into Kelvin, which is 298. Then you place into the values, then you work out. But remember, why am I dividing by 1,000? Remember the units here for enthalpy change, it is in kilojoules per mole. Now, what you do, you ensure also whatever you have calculated here should also be in kilojoules per mole. Then you get the difference, and this one will be your answer. That will one will earn your mark, and that one will also earn your mark. Good. That is perfect. Now, E says use your answer in D to predict whether or not said is soluble in water at 25 degree Celsius. Explain your answer. Now, how did I came up and say no? Because my Gibbs free energy is positive. Now, when you get your Gibbs free energy being positive, this indicates that the reaction is not feasible. Now, this means that the solubility of this compound set or compound said is not soluble in water at 25 degree Celsius. So you just say no, the Gibbs free energy is positive, hence it is said is insoluble. That will also earn your mark. Now, the next one, predict whether said becomes more or less soluble as water is heated from 25 degree Celsius to 95 degree Celsius. Let's come to our equation. You realize that changing keeps free energy depends on temperature. Remember, somebody who is changing here is temperature. So as the temperature increases, the Gibbs free energy will be becoming more negative or will tending to move towards the zero. So as it becomes to be more negative, it indicates that the solubility is increasing. So you say becomes more soluble because the Gibbs free energy will be more negative, or you say less positive or coming closer to zero, it will still you earn your full mark. Yes.